Alright, so briefly the scenario is this. There's a defender in a walled castle, and he's just on patrol or whatever, and he sees a projectile coming over the wall when it reaches the top. The wall is 6 meters tall, and the projectile comes 75 centimeters over the wall, so the height of these, and the soldier obviously runs away from the projectile because it's headed straight for where his feet are. So it takes the soldier half a second to react, and then he sprints forward for the safety of the wall, relative safety of the wall. And basically, I want to know if the soldier manages to escape the shrapnel from the clay jar full of fire and stuff that's being fired at him.
Alright, the pot's about 6 meters and 75 centimeters off the ground, give or take 10 centimeters. Oops.
Alright, now we're measuring the radius of the shards. So the pot shattered over a radius of more than 5 meters. We're gonna have to take a second measurement to get the total length. Okay, so the first thing we need to do is find out how long it took the pot to fall to the ground. We know the wall was 6 meters. We know that it was 75 centimeters above the wall, so the total distance is 6 meters, 75 centimeters. We know that its acceleration due to gravity. We know that its initial velocity was 0 meters per second, but we don't know the time. So we put in the equation, rearrange the equation to isolate time, do the equation, and we get the time is 1 second, 1.17 seconds. The second thing we need to know is how fast the soldier can run to escape from the pot of fun flammable stuff. So, to get this, I ran carrying a bunch of logs, distance 10 meters, average time 2.6 seconds, starting from standing, and acceleration is unknown, so use the same formula. Isolate, this time we plug in the numbers, and we get the acceleration is 2.959 meters per second. Our third and final equation is to find out how far the soldier made it before the pot hit the ground. We're assuming that the pot explodes pretty much instantaneously. I know it's not accurate. Whatever, we can take that out of the 0.5 second reaction time, assuming it reacts faster or something. Anyway, time is the time we found before minus the 0.5 second reaction time. We know his acceleration from our tests. He starts at a standing, and we need to find out how far he makes it. So we get the formula, don't have to rearrange anything, plug in the numbers, and we find out he only made it 67 centimeters. We know that the main diameter of the blast was, or the dispersal of shrapnel and pitch was 2 meters. So 67 centimeters as well within that within the radius of 1 meter. So he's got quite a bit of shrapnel in his legs and lower back, probably some pretty severe burn.